we have seen this problem before yesterday, right? So let me wipe the board down and let's take another journey. We have, it's at 12:35, so that's more than enough time to knock it out. I'm just going to go through it. If you call out certain things, trust me, I'll give you about 30 seconds to tell me what you think it is if you want points, okay? Yes, these points help you. The quarter ends, not the quarter order, summer school ends next week, Thursday. And I think there's a trip changing to a water park thing, right? Make sure if you're going on that, because that's going to be the 22nd. All your grades are going to be done, in my opinion, or in my grade book, I don't know about other teachers, by the 21st. So make sure you finish all that. Okay, so let's get started on this. This is a monster problem. It's like a super algebra problem, but it makes you think. A lot of critical thinking involved in engineering. And we just talked about the purpose of the National Society of Black Engineers, right? So let's look into this, right? Because this is a problem they would do easily, especially if you're looking at how circuits are built, especially electrical engineers. So where does it start at, right? Let's come to the problem and put it on the screen for you to read, or you can read from your PowerPoint slide that I shared with you all. Anybody want to read it for 10 points, though, the problem? If not, I'll read it. Go ahead, sir. Use that bass in your voice. Amplify. Talking all low. You found it? Okay, what page are we going to use for our reference in this green, wonderful green book? Huh? 757. 10 points, Mr. Carson. All right, so we turn to 757, and 757, of course, starts with the terms and the story behind this type of circuit and why resistors need to be combined into one resistor for something called equivalent resistance, right? So to do that, let's rewrite the equations we need. Well, we know the name of this problem is called 3 resistors, right, in series, okay, or a series circuit. We talk about circuits are kind of like NASCAR, it goes in a loop, right? Okay, so with that said, we know equivalent resistance is basically calculated by Req. We talked about this again yesterday. If you want to look at what page is it, you'll know what I'm writing. Look at page 758. Equivalent resistance for resistors in series. So it's Req, subscript Req, write it the same way, plus R2, so R1 plus R2 plus R3. If you remember, like I said before, if it's plus dot, 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 that means if you have R4, R5, R6, so on and so forth. But in this case, we only got 3 resistors like you saw in our circuit to work with. You also need something known as what? Well, this is for equivalent resistance, equitive. But you also need something that deals with electromotive force or voltage. So that was yesterday. What? What was the name of that? Well, this is for, this is one problem on page 750, 758 to 759. That's where this problem is, right? If you want to follow along with me. Okay, so I know that I need Ohm's law. We did this on Monday, and now we're doing an advanced version of it by combining the resistors. So if that's the case, Ohm's law is equal to V being equivalent to I current multiplied by R. A more powerful way to write it, or another version of it is, or we're going to use both of them. You could say epsilon is equal to your current, which doesn't change out the system, multiplied by your equivalent resistance. You're going to see next week with parallel circuits that the current does change because of how they're built in the circuit. Whereas a series circuit, the current just flows around in a loop. All right? That's why it doesn't change. Okay, so we got the tools of the trade for this problem out there. Now we're going to set up our known and unknown values, okay? It's going to be based upon some of these variables that we do or do not have that the problem gave us. So what do we know? So I wish Lake was here. She had a good old time with this problem. Something that you touched on. So known, unknown. This was one of Taekwon's favorite problems. These algebra problems, by the way. So, epsilon. Oh, he didn't get thrown off that time. Yesterday you called it V, sir, or I. Yeah, I was listening to that record and I heard you go I. I'm like, nope. All right, so it is what again, sir? You said 28. Okay, that's 5 points for you. Volts. And then I, his favorite word. Okay, I what is equal to? 0.0567 amps. Okay, pretty good. What else do we have, sir? There's 5 more. You racking up. Okay, and what would that be, sir? 248.33 ohms, you said? Or omega. I would like to see omega in your reports. It's a symbol that you can look up. All right, keep going, sir. You got 15 so far there. Keep going. 199 point what? 66. And omega, or ohm is what it's called. That's a simple mathematics. I want you to get comfortable with this. It scares a lot of students when they get to engineering school of physics. Why are you using these weird symbols? That's applied mathematics. You have to use that. All right? There's even pieces and parts to robots that have these symbols in there. So you gotta get used to it. All right, do we have everything, I think? Let me look here. All right, so now, yeah, we got part A and part B we gotta figure out. Unknown. What do we know? What is this question asking us? And then part B. Anybody know? Anybody know? 6 minutes into the problem. I know it took 20 minutes last time. I'm trying to go down to 15 maybe. Okay, so if you don't know, it says part A. The resistance R3. That's what we're looking for here. And that's some number we're going to figure out with ohms. And then what else? Part B says, hey, what is the potential difference? That's V, right? Voltage. So you got to use V1 to figure out what that is, and we're going to see what that's calculated to using something else. V2, because that's each resistor, right? So we get 3 resistors. And then V3, so each of these are some numbers we're going to calculate at the end, right? Okay, we got that out of the way. It's like going grocery shopping and we have all of our ingredients to cook this problem. Let's begin cooking it. So let's say part A starts over here. And part A, you need to at least figure out or solve for your R3 by figuring out what? Well, you got to use this equation here. Because we have epsilon, we have I, we don't know RQ, but we can use some algebra to get it. And then once we get that, we can come over here and figure out R3 using more algebra. All right, so let's do it because that's what we are. We're soon to be engineers or physicists. So solve for R subscript EQ, or equivalent resistance. You do so by rewriting that equation over there. Epsilon, which means electromotive force, is equal to the current I, there's your amperage, REQ. And that's something we're going to figure out using algebra. Let's rewrite it, put it on the workbench. So epsilon, or electromotive force, is equal to I times REQ. And I would ask Carson what to do, but he's deep into his laptop, so I'm going to keep on working. So what do I do here? This is multiplication. The opposite of multiplication is division. So to do that, we're just going to simply divide by what I don't want next to REQ. And what you do to one side, maybe the other. That allows me to cross cancel and get rid of the current. Okay, moving on. What does this look like now? Well, we know that that's going to become REQ is equal to your electromotive force divided by current. We have plug and play stage, so let's put the numbers in and figure out what it could be. So that becomes what? Well, just rewrite it and put the numbers in there. We set them up in our known and unknowns, right? So that's going to be what? REQ is equal to, that's your voltage there, epsilon, or electromotive force, and volts, right? Divided by your current, which is 0.0567, and that's amps. Okay? So far, so good. So now let's see finally what that's going to be, because we're going to use that to figure out R3. You got a calculator? Anybody calculate it or no? You got it? Then you got to show me what you got. How do you get it? For REQ. You got it? 506.17. Pearson, you got 10 more for that, man. Are you tracking yourself? Or you got like 20 right here. 506.17, right, Tyshawn? Omega is the resistance. All right, pretty good. Do not stop. I got a noble that says can't stop, won't stop. Keep going. Can't stop, won't stop. We're going to keep on going, though, right? So next step. You want to figure out R3 because you have access to it. You know what REQ is. And we can use this big equation up here for equivalent resistance to get to R3. Just some more algebra. So let's do that. Next step, solve for, what do we say, R3, right? To do so, we're going to grab this equation. Let's put it on the workbench. And that's going to be R1 plus R2 plus R3, right? Everybody good so far? So let's keep on going, right? I'm going to rewrite the equation again. And this is going to be a step we do. So REQ is equal to R1 plus R2 plus R3. Now I want to get R3 isolated, so I got to do the opposite of whatever it is that's next to it, right? So I got R1 as a culprit, R2 is a culprit. I want to get on the other side and get it by itself. So I'll just do the opposite to annihilate those. So minus R1 plus, not minus, but another minus, not plus, R2. Well, what you do on one side, you got to do to the other, so don't get sloppy. Let's move this over a little bit. It's going to be minus R1 minus R2, put a little plus sign right there. It's a step. These cross out, and these cross out. So new equation, you see R3 is just by itself now. We rewrite it as what? Let's write an iteration of step. So that becomes REQ is equal to a negative R1, right? Minus R2 plus R3. Oh, I did that wrong. R3 is going to be over here. Oops. R3 and REQ is over here. That's what it is. There we go. Woo. Moving too fast. All right, so let's plug and play. It's going to be a little long over here. All right, so we know that R3 is going to be equal to, let's plug the numbers in. So that's a minus R1. Make sure you put the minus sign there. Use parentheses that helps you in the calculator. 248.33 omega ohms minus, because that's R2. Make sure you use the same equation. The signs will throw your number off. And R2 was 199.66 omega plus what? REQ. We figured that out. We're just going to grab it from over here and use it. So we know REQ to be what? Well, we calculated, or Mr. Carson got 10 points for saying 506.17 omega. All right, Mr. Carson, you want to get 10 more points? This is a long calculation. Or you want me to do it? I think he said, no, you got it? This is one right here. The first one you did, man. Can you show me your calculator that you did it, or are you just looking at your screen? I don't want you guessing at no numbers. That's a negative. You use that little dash at the bottom, not the minus sign. You use that. That'll be the same as minus. 58. Oh, well, so it changed the number, didn't it? 58. Okay. So you got what, sir? 58.18 omega. Okay. All right. So that's 10 points for him. I'm hoping that's correct. It's really small. But anyway, we're going to continue on. We now need to do part B. This is everything to get part A. So let's finish it off because it's 11 minutes of class left, and we've been on this for like 14 minutes. Yesterday it was 19, almost 20 minutes, so we're doing better. It means people are getting comfortable with the mathematics. So part B. Let's finish this off, and we're calling it a day. So what is that? Solve for V1. And again, I'll give you this video on SB, so you have to finish it at home if you choose. All right? And what does that mean? So again, for potential difference, you use this. If you're dealing about electromotive force, you're dealing with this. That's epsilon. So we're going to use this for each potential difference. And that is also your word of the day for your exit slip, so make sure you define it in words. So to define potential difference, we're going to say, hey, how do we find V1? Well, that's V1 is equal to I, current doesn't change in series, and R1. Makes sense, huh? Because that's across resistor 1. All right, let's plug the numbers in. V1 is equivalent to, what was our current? It's this long number, 0.0567, put A for amps, multiplied by our resistor, which was at that time 248.33 omega. So that leaves V1 to be something that you got to calculate. Question mark volts. Anybody can get 10 points for each of those, you can tell them. And like we did yesterday, we had V2 and V3. So V2 is I, it doesn't change, it's a series circuit, and it's R2 this time, right? So let's plug the numbers in for that. V2 is equal to, I was this number up here, this stays the same, okay? Multiplied by, what was our R2 value? Let's come over here and look at that. That is 199.66 omega. Somebody can figure out what that's going to be. Then we got V3, of course. All right. If I got question marks there, that means you still got to figure out what it is. Don't leave those blank. All right. If you leave before class, you can tell me. I'll rewrite them in, and that'll help out everybody. But you have to calculate those parts. Okay. So I was sitting there. I'm going to take off. So V3, just to give you extra help, is I times R3, and R3 we found here. That's Mr. Carson calculate that, so that's V3 is equal to the same current, right? 0.0567A for amps multiplied by what he said it was. He said that would be 58.8 omega. V3 is some number you have to figure out in volts. Okay? So I think that is everything you need. We did better. Last time it was 20 minutes. We did 3 minutes short. You had to turn in all parts. It's 12:52. You have approximately 8 more minutes of class, and you put a clock of 7. And after that, you need to turn it into ESB. Now keep in mind, I need to see it in Messenger for Ashley. Mr. Carson, your class is effectively in ESB. You can see it. So click on the assignment, put it in there. You know how, because you had my class before. PDF, and don't forget about your exit slip up here. In fact, let me put the exit slip back up for you. So it's this. If you can't see it in my PowerPoint I gave you, it's on the screen right now. And if you need me to send it to you again, I can. You guys have until tomorrow morning to finish all parts, because we're going to have a new assignment in the system by tomorrow. I will not be in class. I'll be at the Computer Science Teachers Association conference, but you will have an assignment. I encourage you to come to class, because if you don't, I don't want it to knock off your attendance, which could possibly make you fail. All right? I'll be there on Thursday and Friday. Friday is a quiz. So look at the video. I'm trying to make a video tonight of how to do a different problem. But really, you have to complete it using my video and the knowledge you have from the document I gave you in ESB. You have an exit slip, you have words, all that. But check ESB, even if I'm not here, finish your work, because I don't want nobody, you mess my grade up, right? Okay, so that's everything. Let me set a clock for you all. Let me stop this thing. There it goes. I'm trying to find the right screen.